We can map brain activity with scanners and even simulate simple nervous systems with computers. But here's the shocking part. We still don't know why consciousness exists at all. We know how neurons fire, how memories form and change, and how electrical signals travel in the brain, yet science hasn't explained how these physical processes give rise to subjective experience, that inner I that feels, remembers, and thinks. Is consciousness just complex computation? Or is there something about neural networks we fundamentally misunderstand? Neuroscience can predict behavior and brain responses, but it can't say why those patterns feel like something rather than nothing. Some philosophers call this the hard problem of consciousness, and so far no experiment has solved it. Consciousness isn't just an academic issue, it touches on everything from artificial intelligence to what it means to be alive. And as you might guess, that takes us deeper into the heart of matter itself. Which brings us to another fundamental riddle: why there's matter at all. Imagine the early Earth, billions of years ago, a world without plants, without animals, maybe without even cells. So how did life start from non-living chemistry? Scientists have built molecules like amino acids in labs that mimic early Earth conditions, and theories like the primordial soup and deep-sea hydrothermal vents help explain parts of the puzzle. But the moment when chemistry turned into self-replicating life is still unknown. Even more baffling is how the first cell developed complex features like membranes and genetic material. Was it inevitable chemistry? Was it a rare fluke? Or was there something about Earth's early environment we still don't grasp? Despite decades of research, we have possibilities, but no definitive answer. Understanding the origin of life isn't just academic. It reshapes how we search for life on other planets and what we consider living in the first place. But once life exists, consciousness emerges. And that leads us to our next unsolved mystery. What if I told you that most of the universe is missing, and we don't know where it went? That's one of the biggest puzzles in science today. When we look up at stars and galaxies, we see glowing objects held together by gravity. But when scientists calculate all of that visible matter, it's nowhere near enough to explain the gravity needed to keep galaxies from flying apart. This invisible stuff has a name: dark matter. Astronomers can see its gravitational pull on stars, but they still don't know what it actually is. It doesn't emit, absorb, or reflect light, and no detector on Earth has ever captured it directly. Meanwhile, the expansion of the universe isn't slowing down like you'd expect due to gravity, but speeding up. This unexpected acceleration is attributed to something even stranger: dark energy. We can measure its effects, but we have no idea why space itself pushes galaxies apart. Is it a property of empty space, a new field we've never discovered? No one knows yet. This mystery matters because dark matter and dark energy together seem to make up about 95% of the universe, leaving only 5% as the normal matter we understand. So in one sense, we know the universe exists, but almost everything in it remains a mystery. And that leads us straight into another deep mystery: the very beginning of life itself. Most of us have seen lightning, the brilliant flash and thunderclap during a storm. But some witnesses describe a completely different sort of electrical phenomenon: ball lightning, glowing spheres of light that appear during thunderstorms and linger for seconds rather than milliseconds. Although documented for centuries, scientists still don't fully understand what they are or how they form. Researchers have recreated effects in laboratories that resemble ball lightning, but nobody has yet nailed down a full explanation. Is it a form of plasma? Some kind of electromagnetic bubble? Or something completely different? We have glimpses, models, and theories, but no definitive answer. This mystery shows that even phenomena sparked by everyday storms can still stump modern science, and reminds us that for all we know, there's still so much yet to be discovered.